Okay, now let's see how we solve the problem S3 in Python. And here is N and M are the size for the grid. This is how many rows and how many columns. And grid is a two-dimension array. And be careful about how we declare the two-dimension array here. Empty cell is a map to check the empty cells, and the value are the steps to get to this cell. And then we have accessed cells, that is to track all the cells that we have accessed. And as we are using tree as a structure here, and those are also the nodes in the tree. And then we have a function camera path to say if a cell that can be seen through by a camera, if it's an empty cell, or if it's a conveyor, then the camera can see through them. Otherwise, false is returned. And then we have a function is on the camera. This is to check whether the cell is on the camera or not. If the content at this cell is a C, definitely it's on the camera. If it's an empty cell or the start point, and then we need to check in the four directions up, down, left, and right if there is a camera far further or not. If there is, then true is returned. Otherwise, the cell is not under camera. It's safe. And then we have this access. This is to check whether this location is in access cells or not. This is to indicate whether we have accessed this cell or whether the node is already in the tree. And then we have the check cell function. We have an array same level. This is for conveyors, as if you have a conveyor there, then when the conveyor moves, the steps does not increase. The ending cell on the move path of the conveyor need also to be processed in this function. Then we go through the element in input, and that's for the nodes at the same level in the tree. And if it's already in access cells, then we skip it because it's already processed. If it's not, as we are not going to process it, we put it into access cells. And then we get to the content at this location. And if it's an empty cell, then we check whether it's under camera or not. If it's not, if the step for this location in empty cells is not set yet, we set it to steps. And then we need to check the surrounding cells if they've not been accessed and they're still in boundary, then we put them into output. Those are the next level of nodes that need to be processed. And then if it's an L or R up and down, then it's a conveyor. Then we need to move the conveyor to get to the ending cell. And then as this ending cell need to be processed here in this function, we put them into same level. It's not in the next level of nodes to be processed. It's at this level. We need to process at this level. And then if it is starting point, then we don't need to set any steps, but we need to check the surrounding cells. And then we swap same level and input here, and go back to the loop and check the input, which is basically check the elements in the same level in the last iteration. And then we have getSteps function. This is to be called and with the start point and the initial steps that should be 0. And then we put the start to the output, that's for the root of the tree, and then we get the loop. In the loop, we swap input and output, and we get to the next level of the tree. At the start, we get to the root of the tree, and then we call check cell. And then after each time, the tree in the tree structure, we should go down one level, and the steps need to be increased by 1. And this is the main line. So here we process input first. We read in the first line, and we convert it from string to integer, put them to n and m. That's the size for the grid. We initialize the size of grid as a two-dimension array. The first dimension is n, that's row-wise, and the second dimension is m, that's column-wise. And then we loop through them, and we read in each line, and we put each character on each line to the grid for each cell. And if it's ice, then we know this is a start cell. We remember it. And then if it's an empty cell, we put it into the empty cells map and put the initial value -1. And then we need to calculate the steps. We check first if the start cell is on the camera or not. If it's not, then we call get steps. If it is, that means from the start the robot can move. It can get anywhere. And then if it's not, we call get steps to get to process each cell along the way. And then after the calculation, we do the output. We go through empty cells, and we print the value for each element in the map out. The map is already ordered, so the steps printed out are also ordered. Okay, so that's the program in Python for problem S3. Now let's test the program against the samples in the problem. Okay, now we are ready to test the program against the sample 1. We already have the input in the clipboard, and now we paste the input here and press enter. And we get the output is -1, 2, 1, which is exactly same as the output in the sample. So our program works well for sample 1. And now let's test sample 2. Okay, now I have sample 2 in clipboard, and now paste it here, press enter. We have 2, 1, 3, -1, -1, and 1, which is also exactly same as the output from sample 2. So our program works for sample 2 as well. This means that this is the right code for problem S3, and our solution works. And this is the right solution to this problem. Okay, I hope you guys enjoyed the video. If you like it, please thumb up, and please also subscribe to my channel. I'll have videos for more problems. You won't want to miss them. I'll see you soon.